It is true that the real-world numbers from major logistics companies tell a story that is rarely shared with the public. They reveal why an increasing number of transportation companies are prepared to invest billions of dollars and place the future of their businesses on the Tesla Semi. But what exactly gives the Tesla Semi such a strong advantage over traditional diesel trucks, especially when traveling across steep mountain roads? The outstanding performance and cost savings reported by these companies come from several key improvements that have surprised many experienced truck drivers during their first time operating the Tesla Semi. The biggest difference is not simply its rapid acceleration or impressive pulling power. Instead, the real breakthrough comes from how the truck performs on long and demanding mountain routes. This is not based on excitement over a new technology or personal opinions. It is a measurable advantage that drivers notice after years of operating conventional diesel trucks. One of the Tesla Semi's greatest strengths appears when traveling downhill through mountainous terrain. Instead of using energy to move forward, the electric motors automatically switch into generator mode. As the heavy truck descends, the kinetic energy created by its massive weight is converted back into electricity and returned to the battery through Tesla's regenerative braking system. This technology provides three major advantages that conventional diesel trucks simply cannot achieve because of the limitations of internal combustion engines. First, the mechanical braking system is used very little during long downhill sections because the electric motors generate enough braking force to control the vehicle's speed smoothly. Second, brake temperatures remain significantly lower, greatly reducing the risk of brake fade caused by overheating, one of the leading causes of serious accidents on steep mountain roads. Third, instead of wasting energy as heat and loud engine braking noise, the Tesla Semi is able to recover roughly 80 to 90% of that energy and store it back inside the battery for later use. For diesel trucks, every downhill section increases brake wear, maintenance costs, and safety risks. For the Tesla Semi, every descent becomes another opportunity to recover energy while extending driving range. One of the clearest demonstrations of this advantage came from testing at Donner Pass in California's Sierra Nevada mountains, one of the most demanding trucking routes in the United States, with grades reaching approximately 6%. While many diesel trucks carefully descend, using continuous braking at relatively slow speeds, the Tesla Semi reportedly maintained a steady pace matching traffic flow without requiring constant use of the brake pedal. At the same time, it continued recovering large amounts of electricity through regenerative braking. On exactly the same mountain route, the economic and safety differences between electric and diesel technology became increasingly clear. More importantly, this capability cannot simply be added to diesel trucks through aftermarket upgrades or optional equipment. Regenerative braking is a fundamental characteristic of a fully electric powertrain. Although several manufacturers have experimented with energy recovery systems on hybrid vehicles, those systems deliver only a fraction of the efficiency achieved by a fully electric truck because of smaller battery packs and far more complicated mechanical systems. Hybrid vehicles still depend heavily on conventional friction brakes, which continue wasting large amounts of energy as heat during braking. This remains one of the biggest technological barriers that traditional combustion engines cannot easily overcome through gradual improvements alone. Even more convincing is the growing amount of real-world data collected by major logistics companies demonstrating the economic advantages of the Tesla Semi. These results have moved well beyond laboratory testing or manufacturer claims since Tesla officially began volume production of the Semi at Gigafactory Nevada on April 29, 2026. Large-scale fleet evaluations have been designed specifically to support multi-million-dollar purchasing decisions based on real operating conditions. Independent testing from the North American Council for freight efficiencies run on LESS program provided particularly valuable insights. Tesla semi-trucks operating within PepsiCo's fleet successfully completed routes exceeding 410 miles, or roughly 660 kilometers, on a single charge while carrying full loads. In another demonstration, one vehicle reportedly traveled approximately 1,050 miles during a single 24-hour period by taking advantage of rapid charging between driving shifts. These results helped address many concerns surrounding the practicality of electric trucks for long-distance freight transportation. Looking at operational data from participating companies, ArcBest reported average energy consumption of roughly 1.55 kilowatt-hours per mile after a 3-week evaluation across a wide variety of road conditions. Not only did this closely match Tesla's published efficiency targets, but the results also proved even more consistent than ArcBest's own engineering team had initially predicted. Meanwhile, DHL supply chain achieved approximately 1.72 kilowatt-hours per mile, while regularly operating at maximum payload capacity. Following these successful evaluations, DHL officially expanded the Tesla Semi into broader commercial operations. The financial benefits become even clearer when energy consumption is converted into actual operating costs. With average efficiency of around 1.6 kilowatt-hours per mile and typical commercial electricity prices across the United States, operating a Tesla Semi can cost approximately 15 cents to 20 cents per mile. By comparison, a diesel truck averaging around 6.5 miles per gallon generally spends about 50 cents to 60 cents per mile on fuel alone. That means the Tesla Semi can reduce direct energy expenses by well over 60% for every mile traveled. Environmental benefits are also becoming measurable. Several logistics companies have reported significant reductions in carbon emissions while testing electric freight operations. For example, SA Logistics estimated a reduction of approximately 4.38 tons of CO2 during one of its pilot programs. Other companies, including MDB Transportation and AIO Logistics, conducted 3-week evaluations on busy port routes involving constant stop-and-go driving. These urban operating conditions proved especially beneficial because regenerative braking could recover energy almost continuously throughout the day. Perhaps even more impressive is that multiple companies operating under completely different conditions achieved similarly positive results. This consistency strongly suggests that the Tesla Semi's advantages extend far beyond isolated success stories and instead represent a broader shift in commercial transportation. Despite the impressive efficiency demonstrated in nearly every real-world evaluation, the widespread transition to electric trucking cannot happen overnight. The primary challenge is no longer the performance of the Tesla Semi itself. Instead, the biggest obstacles are charging infrastructure and production capacity. A good example is Covenant Logistics, whose testing program clearly demonstrates the difference between ideal operating conditions and large-scale commercial deployment. During its evaluation, Covenant Logistics operated the Tesla Semi on a daily route of roughly 200 miles. This type of operation is nearly perfect for an electric truck. The vehicle leaves the distribution center in the morning, completes its assigned deliveries, and returns to the depot where it can recharge overnight. Using a dedicated 125 kilowatt charging station, which requires an investment of approximately $20,000, this closed-loop operating model works extremely well without relying on public charging infrastructure. However, the situation becomes far more complicated for large logistics companies managing nationwide freight networks. Many long-haul routes extend well beyond the Tesla Semi's estimated 500-mile driving range, making public charging infrastructure far more important. At present, Tesla's megacharger network is still expanding and does not yet provide the widespread coverage required for every interstate freight corridor. Building megacharger stations based on the Megawatt Charging System, or MCS standard, is also a significant undertaking. Each charging stall can require between 1 and 3 megawatts of electrical capacity, roughly equal to the power demand of a small industrial facility. Because of these enormous energy requirements, Tesla and commercial fleet operators must work closely with local utility providers to upgrade substations and strengthen electrical infrastructure. These upgrades often require months, and in many cases even years, to complete due to permitting, construction, and regulatory approval processes. Charging infrastructure is only one side of the equation. Tesla is also facing tremendous pressure to increase production in order to satisfy rapidly growing demand. The dedicated Tesla semi-factory in Nevada has been designed with a long-term production target of approximately 50,000 trucks annually once full capacity is reached. However, industry estimates suggest that actual production during 2026 could remain between roughly 5,000 and 15,000 units. That represents only about 10 to 30% of the factory's intended production capability. The primary reasons are ongoing supply chain limitations involving large-format 4680 battery cells and high-performance semiconductor components required for heavy-duty electric trucks. Meanwhile, orders from major commercial customers continue to grow. Companies such as PepsiCo and DHL have already committed to expanding their electric truck fleets. One of the largest publicly announced orders comes from Watt EV, which has placed an order for approximately 370 Tesla semi-trucks. As more businesses commit to electric freight transportation, demand is beginning to exceed Tesla's current manufacturing capacity. This growing gap between production and customer demand presents one of Tesla's biggest challenges over the next several years. To maintain momentum, the company will need to significantly expand manufacturing capacity during the next 18 to 24 months. The next question naturally becomes whether the shift toward electric trucking will become unavoidable once the financial equation is fully solved. For decades, diesel truck manufacturers continued improving internal combustion engines through technologies such as variable geometry turbochargers, high-pressure common rail fuel injection systems, and increasingly refined combustion designs. These innovations certainly improved efficiency and performance. However, they mainly represented gradual refinements to an engine technology that had already approached many of its physical limitations. They never completely solved the biggest challenges associated with heavy freight transportation across difficult mountain terrain. Problems such as overheated braking systems, reduced engine performance on steep climbs, and large amounts of wasted energy continue to affect conventional diesel trucks. Electric powertrains approach these problems from an entirely different direction. Because electric motors deliver instant torque, regenerative braking, and much higher energy efficiency, they offer structural advantages that conventional combustion engines cannot realistically duplicate. For this reason, many experts believe mountainous freight routes will likely become some of the first areas where electric trucks begin replacing diesel-powered vehicles on a larger scale. These are the routes where brake wear is highest, safety risks are greatest, and operating costs increase significantly for traditional trucks. In these demanding environments, the Tesla Semi's technology provides advantages that extend far beyond simple acceleration or environmental benefits. Instead, it offers measurable improvements in safety, operating efficiency, maintenance costs, and long-term profitability. All of these factors are becoming increasingly important as transportation companies look for new ways to reduce expenses while improving fleet performance. The real-world vision becomes much clearer once electric truck savings move beyond pilot projects and become an essential financial strategy for logistics companies. Covenant Logistics is not a technology company, and its executives have no reason to promote Tesla without solid evidence. In fact, during the first quarter of 2026, the company faced growing economic pressure and implemented major cost-cutting measures. As part of those efforts, Covenant removed approximately 422 older diesel trucks from its fleet, while adding only 53 new vehicles. The goal was simple: reduce operating expenses, improve financial stability, and strengthen the company's balance sheet. It was during this period of careful spending that Covenant decided to dedicate 3 weeks to evaluating the Tesla Semi under real operating conditions. The results suggested that the operational savings offered by electric trucking were significant enough that financial executives could no longer ignore the potential benefits. When fleet managers, people who analyze every operating expense and carefully examine every cent spent per mile, begin shifting from skepticism to confidence, it signals that the industry may be approaching a major turning point. The growing number of successful evaluations across several large logistics companies is no longer just an isolated trend. Instead, it points toward a much larger transformation taking place throughout the freight transportation industry. Electric trucking is gradually moving from an experimental technology to a practical business solution. Companies are no longer evaluating the Tesla Semi simply because it is an electric vehicle. They are evaluating it because it has the potential to lower operating costs, improve safety, reduce maintenance requirements, and increase long-term profitability. If these advantages continue to grow as charging infrastructure expands and production increases, the transportation industry could experience one of its biggest technological shifts in decades. For years, diesel trucks have dominated commercial freight because they offered proven reliability, widespread fueling infrastructure, and dependable long-distance performance. Now, electric trucks are beginning to challenge that dominance with lower operating costs, advanced technology, and improved efficiency. As battery technology improves and charging networks continue expanding, many transportation companies may find it increasingly difficult to justify staying with traditional diesel fleets. Tesla's biggest challenge is no longer proving that the Semi can perform. Real-world testing has already demonstrated that it can successfully handle demanding freight operations. The next challenge is producing enough trucks to satisfy growing customer demand, while expanding charging infrastructure quickly enough to support large commercial fleets. If Tesla succeeds in overcoming both of those obstacles, the Tesla Semi could become one of the most disruptive products the trucking industry has seen in decades. The transition from diesel to electric freight transportation may not happen overnight, but the direction of the industry is becoming increasingly clear. More logistics companies are focusing on operating costs rather than tradition. Instead of asking whether electric trucks can replace diesel vehicles, many businesses are beginning to ask when that transition will make the most financial sense. That shift in thinking may ultimately become the strongest indication that the future of freight transportation is already beginning. So, what do you think about the Tesla Semi and its growing impact on the trucking industry? Do you believe electric trucks will eventually replace diesel-powered freight vehicles? Or do you think traditional trucks will continue dominating commercial transportation for many years to come? Share your thoughts in the comments below. If you enjoyed today's video, don't forget to like, subscribe, and turn on notifications so you never miss our latest updates about Tesla, electric vehicles, and future transportation technology. Your support helps us continue creating more informative content for the channel. Thank you very much for watching. We truly appreciate your support, and we'll see you again in the next video. Until then, stay safe, take care, and thanks for watching.